Okay, so what are our base units for length? Is meters. Oops, hold on, let me go back. Is meters. For mass is grams, and for volume is liters. So those are our base units. And so what happens is if I have 1 meter, then we want to convert that to maybe something else, maybe kilometers or nanometers. So we know that kilo, for every one of these, hold on, oops. How many meters, or how many millimeters are in 1 meter? Does anybody remember? Back from 8th grade, or 1,000. For every 1 meter, there are 1,000 millimeters. Well, if we go back the other way, what if we go kilometers? For every 1 meter, how many kilometers is that? Instead of multiplying by 1,000, this time we're going to divide by 1,000. So 1 meter is 0.001 kilometers. King Henry, so King Henry died by drinking chocolate milk. By is our base. That is our meters, grams, and liters. So then you guys have to decide which way are we going to move the decimal. And each one of these is, this is 10, hundreds, thousands, and then, or tenths, hundreds, thousands, and tens, hundreds, thousands. Okay? So, 256 meters, how many centimeters would that be? We're going from here to here. 25,600? 25,600? Yes. What about if we wanted to go back the other way, so 25,600. Now we're going from centimeters to millimeters. So we're only going over how many places? We're only going over 1. So that turns into what? 972.5 millimeters. Yes, 2. Okay? And I'm going to do one more with you guys. Let's look at, we're going from meters to centimeters. So how many places are we going to move? In which way? We're going to move in this way, and we're moving in how many places? 1, 2, 3. 3. So it would be 500, and, 2, sorry. I went 1 too far. 57.4 meters. Okay? I'm not going to just sit there and give you a quiz on this, but this will be all the time. I'm going to give you a question, and your question will be given in 1 millimeters, but my answer may have to be in kilometers. So you're going to have to watch your units and see what units. Read your question, read the units, and see what the final answer has to be. So it's King Henry died by drinking chocolate milk, and then whichever way you're moving that decimal. Are there any questions over that? Basic review. I'm not going to sit here and do much lecturing over it. Everybody good? Okay. So next, I'm skipping that. If you need practice, it's there. So here are some vocabulary words. I'm not going to sit here and wait for you to write these down, but these are words I expect you to know. I don't expect you to go and define every single one of them. When I give you test reviews, I say know these words. I'm not going to sit there and waste time and paper by you guys going out and defining it. Go look the word up if you don't know what it is. Okay? So you need to know what an SDS is. You need to know what chemistry is, physical change, intensive property, density, gas, liquid, structure, the word characteristic. If I said differentiate, you need to know what that means. What a chemical property is, extensive property. What is a compound? What is an element? If I say something is heterogeneous, you need to know what heterogeneous means and homogeneous. What is a mixture? What is solid? What is volume, matter, chemical change, physical property, and element. These are all words you're going to hear me saying throughout this unit. Okay? So don't go out, unless you like to go out and define words. I just want you to know, I'm going to put these up. Every time we have a unit, I'm going to put academic vocabulary words. And those are words that I'm going to be using, and those are words I expect you to be using too. So let's go ahead and just start. Matter. So somebody, tell me, what is matter?
Everything.
Everything? Yes, say it. Everything, okay? Everything is made up of matter. So, let's define it this way. It is anything that takes up space anything that takes up space.
Wait, hold on. So would something like what about like a conversation, like the radio wave on a phone? Like, would that be matter?
Like the sound waves and stuff?
Yeah.
Those are mostly waves.
So like, it's not
Everything, anything that takes up space, and
like.
I'm trying to think of what my other keyword is. Hold on. Okay. Anything that takes up space and has mass.
Oh, it has to have mass.
So radio waves do not have mass.
Do not have mass, yes. So anything that takes up space and has mass. All right. So the types of matter that we care about in here are solids, liquids, and gases. Okay?
Elements.
Huh?
Basically elements.
Yeah, not necessarily elements, compounds, mixtures. Can matter be put into all of these categories? Can all matter be put into these categories? Can you somebody tell me what is a solid? Yes, Evan.
Just something that can hold a shape without easily being moved and hold a solid shape, basically.
Okay. Something that can hold its shape. Does it have a definite volume? Does your solid have a definite volume? Yes. Does it have a definite shape?
Yes.
Yes. Okay, so that's how, and I'm going to come back and write this down. What about a liquid? Well, how would we define a liquid? I like to define it in the words of volume, so space, the volume, and the mass. So how would we define a liquid in that?
It does not have a defined shape.
Does it have a defined shape?
It fits like the container.
It fits the container. Does it have a defined volume?
Yes, it does.
It does. Okay? Good. Great example there sitting on the desk. What about our gas? The air we're breathing.
Does it have a volume or does it have a shape?
It has shape and it has volume, but it doesn't have a defined. Okay, so keyword defined. Now, can all matter be put into these categories? Can somebody think of something that cannot be put into this category? Yes, Evan. Plasmas, okay. So I think in middle school you guys talk about a little bit about plasma. We just don't even take that into consideration. What about something else that you see every day? So what's the big thing that everybody's been making at home?
No, slime.
Slime. Okay.
I haven't made it. It's really switching.
Slime. What about, does anybody know what oobleck is?
Yeah.
Okay, what is oobleck?
It's like
cornstarch and water.
Cornstarch and water, okay? Cornstarch and water. Sometimes it is solid, and sometimes you can just put your hand through it and it will go all the way through like a liquid, okay? If you've ever seen, what they can do is they make it dance. They put a speaker next to it and they make the oobleck dance. It's really cool. So those might be some objects that we find challenging to classify, right? Slime, oobleck. I don't know, Jello. What is there? Jello might be kind of hard. So why are those objects difficult to classify as either a solid, or a liquid, or a gas? Yeah, because they can't hold a shape, yet they're solid. It's just kind of weird. I don't know. Okay? Does anybody have any questions about that? So what we're going to do next. Everybody good before I change the slide? Is the following. I am going to skip this slide real quick. I am going to put up a Venn diagram, and I am going to give each one of you, and some of you might have to share, some words. And what you're going to do is you're going to go and place your magnet into the spot that you think it fits. How would you classify? So I'm going to modify this. Here we're going to have a liquid. Here we're going to have our gas. And then down here, we're going to have our solid. So, I want to just pass these out. Take one, pass it back. If somebody doesn't get one, then you guys can share. But I don't think I have exactly 28. Anybody not get one? I can bring one. Okay, so take a look at what you're given. If you're having problems, go to the board and put it in one of those circles. Let me hit the record button. My suggestion is I would know this, like the back of your hand.
So we need to write that chart out?
I mean, I would know it, so you either write it down, go back and copy it, go watch the video, fill it in somehow. So we have solid, liquid, and gas. And we're going to talk about these properties. And the properties we're going to talk about is the shape, the volume, the structure at the microscopic level. What does it look like? The compressibility. How can we smush those particles in closer together? And the energy. How are those particles moving? Okay, so one of the big things is knowing at the particle level what is going on. And a lot of the words I'm going to use, it's going to be like, they're short and to the point. Definite, indefinite. So if we think of a solid, the shape of a solid, is it definite or indefinite? Definite. Okay? And as we talked earlier, what about the volume of a solid? What about the volume of...
That's definite.
It is definite. Now, when we look at the microscopic level of a solid, what we're going to see is something that is highly organized. So, here is my solid.
So gas is unorganized.
What about the compressibility? Can we compress those? Somewhat, okay? So it's going to be low. We're going to have low compressibility.
Where do you find this? Like, are we supposed to be filling this out?
Huh?
Are we supposed to be filling this out, or do we draw that on there?
You can fill it out. You can fill it out in your good notes or whatever, or in your journal. The compressibility is low because these particles are in fixed positions.
So a lot of this is based on temperature. You know?
Did you say temperature?
Uh-huh.
Some of it. I mean, some of them will change based on temperature.
Because when you, the higher you heat up something, the less compressibility comes. You know?
Or more.
It's going to become...
Oh, more. Yeah.
Yeah.
More. Because you can bring it.
Right, but what happens when you heat up the temperature to a solid? What's it going to happen? Think of ice.
No.
It starts to become what?
It's a liquid.
And then after a liquid, it starts to become
Yes.
a gas.
So,
So what about the energy? Yes.
Oh, sorry. Ranks are highly organized. What's the first in the column? What does the word next to it say?
I put BC for because.
Oh, no, I'm sorry. Where it says
Oh.
highly organized.
High.
Microscopic picture.
Structure, microscopic. The energy is going to be low. Again, they're in fixed positions. They can't move very much. Any questions on a solid? What about a liquid? How would we define the shape of a liquid? Undefined. Easily changes, right? Or you could say it takes the shape of the container. If it's in a cylinder, it's going to take the shape of a cylinder. If I put it into a box, it's going to take the shape of a box. What about the volume? What would we say about the volume of a? It is definite, unless you spill some when you go to transfer it from one place to another. And then when we go to talk about the structure, what happens is these start to become less organized. Okay, so it's less organized. How about the compressibility of a liquid? You can't, so we're going to say it. So sometimes you can compress it a little bit, but not very much. So we're going to say somewhat, a little, more than a solid. And what happens when we compress these, they start to slide over each other, okay? Oh, that is just a word I made up. Each other. So they slide past each other, and the energy is going to be medium, more than a solid, but less than gas. Any questions over that? What do you want to say about a gas? What's the gas's shape? Indefinite. The volume is indefinite. We can take the gas that's in here and we can compress it down further. What about the structure?
Highly unorganized.
Highly unorganized. And they're going to be very far apart from each other, okay? So, unorganized. These guys are bouncing around, traveling really fast. So compressibility is going to be highly compressible. And the energy is high. So what I want you to do is together, get in groups of 3 or 2 or however you want to work together. What I want you to do is the following. We're going to take matter. So we went from our states of matter, solid, liquid, and gas. Now what we're going to do is we're going to take those and we're going to classify them as to whether they are elements, compounds, or mixtures. Okay? So we take all of our matter and we can classify it into those 3 categories. So with your team members, what I want you to do is take a few minutes and describe the difference between these 3 and what might be some common examples of each, and then be prepared to share out. Okay? Is there any questions as to what you're doing?